Okie dokie. So of course, last time we were talking about the C++ versus Python. And hopefully we were seeing that despite the obvious dissimilarities, really at the end of the day, once you boil it down to what's actually important in the code, like the actual algorithms themselves, you realize it's very, 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 very similar. So here's hoping that's kind of the theme that's been going so far. Anyways, let's just get right back to the lecture. As always, raise your hand, type things in the chat if you think of anything, and we should be good to go. Okay, I'll just go back to chat. All right, so this is where we were. Let me make sure everything's working okay. Looks good. All right, so here's a very simple function in Python. Convert a temperature from Fahrenheit to Celsius. It takes a value Fahrenheit, and it just does the math conversion, returns a result. And here it is in C++. And you'll see it's basically the same. The only difference is the same differences we've been seeing so far. We've got squiggly brackets, okay, we've got our semicolons. We have to say what the types are. So this function, f to c, takes a parameter called Fahrenheit. That's gotta be a double. And this variable here, Celsius, is going to be a double, and then it returns Celsius. And of course, we also have the function needs to know what its return type is. And there we go. Last time we did actually talk about the necessity of doing 5.0 divided by 9.0. I think technically we can actually get away with only one of them being a float or a double. And that's because we want to make sure we're doing floating point division, not integer division. So yeah, that's important to keep in mind. Now, function headers and comments, if it wasn't obvious already. So in Python, we do our one-line comments by using like the hash symbol, the pound, number sign, whatever you want to call it, octothorpe. But in C++, it's //. And in Python, if you wanted to have like a comment block, you would put 3 quotes in a row, and then you put whatever, and then you end with 3 quotes. In C++, it's this format. It's like /*. And then you have stars, you know, and then when you want to end it, you got your */. That's it. Did I hear a boop? Nope. Okie dokie. There are about 10... Okay, C++ is a little older. And there's a lot of different conventions that people will follow. You can go pick up 10 different C++ textbooks, and they'll all have a slightly different convention on how you should do like your function header comments. And here's the one I'm going to recommend because it's similar to other programming languages like rules. At the end of the day, I don't really care what format you use as long as it's descriptive and consistent. So the idea is at the top of your function comments, you say like, okay, well, this is a function header for the temperature converter. It gets a temp in F and makes it C. All right, whatever. And then you put like your @param to list whatever parameters you have. Here I only have 1, so I only have 1. But if I had like 5, I'd have 5 of them, each with a description of what they are. And then, I guess I've got a little bit of a typographical error there. And then also you've got your return, and it's going to be the value of the temperature in Celsius. Okay. All I care about is just be consistent. Yeah, there's a line comment. Great. Okay. Booleans and conditionals, like if and else. So here it is in Python. Now this is a silly little example, right? Because some bool is being set to true, so it's always going to be true. So I say if some bool's true, so that condition evaluates to true because true is true. And then we just print out it was true. Otherwise, print out false. Now, you can imagine maybe this is like a user input, I don't know. But this is a value that could change, and depending on whatever the Boolean is here, true, false, it'll print the appropriate statement out. In C++, here's the same idea. What do we see that's similar? Well, okay, we've got our print, we've got our print. Remember, C++ prints are a little different, but there we go. So the two prints are the same. If else looks good. I guess we've got our squiggles. our squiggly brackets there, where this uses the colons. But okay, the squiggly brackets, we're already familiar with that. And I guess the only real difference here on the if is we have to put like the statement that's being evaluated within parentheses. Where up here we didn't need to. I mean, you could have done it in Python and everything would have worked fine, but in C++ looks like we got to have the parentheses. Okay. And I guess other little difference is we got to say, okay, it's a bool. We have to say the type of the variable. And I guess the only other thing too is you see that this has an Python has an uppercase T, C++ has a lowercase t. It's slightly different. Honestly, I never remember. And the way I do it is if I go into here and I type true versus true, I can see that in Visual Studio, it's like, well, this one didn't kind of change color, but this did, which lets me know, oh yeah, this is the right spelling. But I honestly always forget. Same within Python. I'll always flip-flop between the two and just do whatever one works. All right, what's the question? Should there be 2 stars at the start of the comments? I don't think it actually needs to be there. Let's just do a quick test. These are simple questions to answer. Hello. No, we do not, but I think people like to have them for I don't know, consistency. See how like they're all you know, it's easy to tell. Here's a comment. There you are. Just wondering because it was in the slide. Yeah, I don't know. Whatever, it was there. Okay. So hopefully this isn't too bad. You see, it's the same. Just with the C++isms we've seen so far. Oh, you know what? I should turn this light on. There we go. Maybe this will help. Maybe that helps with lighting a bit. But yeah, it's the same just with C++isms. We've got our squiggly brackets, our semicolons, our prints are different. We have to say what the types are. The only real difference here is, okay, the new C++ism is we need to put parentheses around the if, the condition for the if. Great. Booleans if else, and or. All right, well, here we go. So here I'm creating 2 variables, int a, b. See how I'm actually declaring the variables? Let me say this again. So this is where we're declaring the variables. We're telling C++, okay, I'm making a variable a and b, and they're both going to be integers. I could have done these on separate lines. I could have said int a semicolon, int b semicolon, but I just did it one line here because why not? I asked the user, okay, give me a, I put it in a, give me b, put in a b. And then I asked the question, okay, if a mod 2 equals 0, and this is and, I'll talk about this more in one moment, and b mod 2 equals 0, I say both are even. Else if a mod 2 is 0 or b mod 2 is 0, 1 was even, otherwise both were not even. Now because this is an else if, this will be mutually exclusive. So if this if runs where it says, okay, they're both even, it can't possibly tell us that 1 was even. If I didn't have the else and I just had an if, it would have, like if they're both even, then 1 is also going to be even, so it would print both things out, but we don't want that. So that's why we've got the else if there. So it's only one of these things can ever run because we've got this if else if chain. So this is a simple one. Just what do we got? Well, we've got our conditions here. Of course, you probably remember. If not, just a reminder. If you take any value, you mod it to, it gives us, it'll tell us if the thing is even or odd. So basically what this is doing is dividing the number by 2, and it's telling us if the remainder is 0 or odd. If you divide something by 2 and the remainder is 0, it's even. If you divide something by 2 and the remainder is 1, well, it's odd. Why? Because that's what even and odd are. The variables a, b, percent, that's the mod, equals, that's to check equivalency. Remember, a single equals is an assignment, double equals is, it's a question, it's asking are these values equivalent? And I guess the only real difference here that we're seeing versus what we've seen before in terms of Python and the C++isms, I mean, of course, we've got our parentheses like we did before, but we see I guess ampersand, and then these like 2 bars, these like 2 pipe characters. These are the button, this is the key like right above your enter key on your keyboard. You'll see that there's 2 of them here. Let's all right, so the convention here is, so in Python, you write and if you want and. In C++, you use ampersands to mean and. And in Python, or is or, and in C++, or is two pipes. But, so, if you had a single and, or pardon me, if you had a single ampersand and a single pipe here, it would work. Everything here would work. But there's actually a pretty neat little thing that's going on, pardon me, in the back when you use two ampersands or two pipes. And they call it like a short circuit and, or a short circuit or. And what this means is, imagine for a second, I say, let's say A is 11, okay? Is A even? Well, of course not. A is 11. 11 is not even. So I'm asking the question, is A even and is B even? That's effectively what I'm asking. So are these two things both even? Is A even and B even? I know A isn't even. Do I even need to evaluate this question here? Do I even need to run the processor to ask, hey, is B even? Because this is only going to be true, this if statement here with the A mod 2 and B mod 2, this will only be true if both are true. So if the first statement here is false, I know that there's no way this will ever evaluate to true. Meaning, if this is false, I don't even need to ask this question. I could just skip it. Save a little time. Fantastic. The same idea for or. If A mod 2 is even, it's true. And or will be true if either of these things are true. So if A mod 2 equals 0 is true, I don't care what B mod 2 is, because I already know that this whole thing must evaluate to true. So almost always you're going to want to use the ampersand, or like bar, pipe. You're almost always going to want to do the short circuit version because it just speeds things up. Now, can anyone, here's a quiz for you. Can anyone think of a reason why we might not want to do the short circuit version? And I heard a question, what do we got here? So using that will save time and electricity. Exactly, think of the environment. Think of the environment, absolutely. Look at you. We're saving the world one short circuited and statement at a time. But the question is, why would we ever not want to do the short circuit version? Any ideas? All right, it will not give us the option for the odd number. I'm not sure, I think I know what you mean there, but that's not quite what I'm looking for in this example. Number two, it will not give the option for two odd numbers. Oh, I got you. I mean, I like the way you're thinking, but let me give you a different example. Imagine for a second that, you know what, I'll go here and just say, I'll just write some code. Let's say I have if some function is going to be a function, I can't see my keyboard. Where the heck is the ampersand button? There we go. B equals 0. I don't know. I'm using like a simple little thing here. Now imagine some function. So this obviously, I mean, just by the way this is written, you know that in order for this to be syntactically correct, some function must be returning a Boolean, right? I guess we could put asterisks on that because C++ and primitive types, but let's not worry about that. This should be returning a Boolean. So bool true. Or let's say false. What am I doing wrong here? Is it lowercase? There it is. Okay. See what I mean? I always forget these things. What was the question? Okay. What do we got here? Okay. So imagine super important code that must run always, no matter what. And actually, I'm going to switch these things. Okay. So And I did hear another boop. What do we got here? Whoops, I meant caps. Never mind. Okay. Yes, caps. So imagine for a second, I've got this function, some function. And for whatever reason, this function has some super important code that's got to run no matter what. This code has to run. This function's got to run because there's some important code that's inside of it that has to run. And then for whatever reason at the end it returns false. I don't know. Maybe it returns true. It doesn't matter. Let's just there. It assigns some bool. And then down here, okay, great. I don't know what's returning. But the point is this function's running some super important critical code that has to get run. Maybe it's making some alterations in other parts of the software. I don't know. But it's super, super, super important that it's got to run. If I had the short circuit and here, and b was not equal to 0, this function would never run. Which would be a problem if the way I've set my code up requires that this function must run no matter what, because one of the side effects this function has is it's got super important code that matters for the functioning of our software. So if I use the short circuit here and this evaluated a false, it would never run this function. Sure, we've saved a lot of time, but we needed this function to run. So in this particular case, the solution is to go, well, look, here, look. Even if this evaluates to false, if I use 1 amp, and if this evaluates to false, 1 ampersand, I'm still gonna run the right-hand side. I'm still gonna evaluate the right-hand side of that expression, that statement. So this is where we might actually want the not short circuit version. And similarly for the OR. Hopefully that makes sense. And if it doesn't make sense, don't worry about it. Don't worry about it. Not overly important. 99 times out of 100, you're going to want just double ampersands, double pipes. Yep. Oh, and of course, like I've got an and here. If A mod 2 is 0 and B mod 2 is 0, I could just nest these things as well to effectively do the same thing. All right, while loops. By the way, again, any questions at all, throw them in the chat. And actually, let me take a second to do another quick little rant here. In the previous slide, oh yeah, what's up? Or was that in the previous slide? What? Let's see. What was that?
Would it save power to like, or would it use more power to have it in like different indents?
So actually here, let me take a second to talk a little bit about compiled programming languages. So people over the decades have spent okay, first of all, actually, I want to say this is a fantastic question because you give me an amazing segue into some important engineering principles that belong to like C++ and other compiled programming languages. So Python, for example, could be compiled. You can set it up that way, but it's running, you know, it's interpreted. But like your big beefy languages, people are writing like heavy duty software in your C++, your C#, C, Java. There's a bunch more, of course. So here's what happens. When you think about your computer for a second, your computer is just a whole bunch of simple little logic gates, just a whole bunch of transistors that are basically switches, and depending on the sequence of zeros and ones, ons, offs, low voltages, high voltages, the transistors will act in a certain way, let high voltages through, let no voltage or low voltage through. Long story short, your computer only cares about high voltages and low voltages. And we like to think of those things as zeros and ones. 0 for low voltage, 1 for high voltage. Okay? So it's just on, off. True, false, 0, 1. When our processors, our computers, can only accept sequences of information that are zeros and ones. And I know, like, I don't know, like, I remember being like younger and in high school and be like, a computer only cares about zeros and ones. And you go like, yeah, well, okay, obviously that's true, but blah, 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 blah. No, I mean, really though, it really only cares about zeros and ones. When push comes to shove, it's zeros and ones. So a long time ago, if I were programming, I would know what sequences of zeros and ones would mean add to a processor. So I could, in fact, here, I'm going to open up Notepad++. Give me a minute while I try to open up a text editor. My poor work computer is not powerful enough to do anything useful. I love how they think like, oh, computer scientists, your computers that we give you to work with, they don't need to be any more sophisticated than everybody else's, right? All right, here we go. So, okay, let's just talk about this for a second. So imagine for a second, I go look up my processor's things. I don't know, maybe it's a 16-bit processor. And the first 8 bits are, will mean something. Okay, so there's 8 bits, 1 byte. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so for whatever reason, now I didn't design this. I could design a processor, I guess, if I wanted. But these 8 bits here, oh, what's the question? Offer still stands to borrow my laptop. I appreciate it. Gotta bust out the gaming PC. My gaming PC has been out of date since 2008. So there's that. But, okay. There's the sequence of zeros and ones. And for whatever reason, that means add. Why? Because the processor is designed physically in such a way that if it has that series of zeros and ones going into it, it means add. And then I'm going to add the number like 2 and 5 together. Okay? So this should give me 7, right? But so like, I've also note that I've added the spaces here just for visualizing purposes, okay? And this is a really, really, really simple example, but this is effectively how it works. Maybe this sequence, for whatever reason, will do like bitwise and on the input. So of course this would evaluate to, okay, 0, 0, 1, 1. Oh wait, I guess there, that's right. And this would evaluate to I guess 0, 1, 0, 1. Great, because bitwise and 1 and 1, 1 and 0 is 0, 1 and 1 is 1, 1 and 0, 0. Okay, great. The nitty-gritty details of this aren't important, but this is what the computer wants to see. So if you go and you're trying to program like this, imagine trying to program with like 0, 1, 0, 0, 1, 0, 1, 1, 0, 0. Like imagine doing that. Of course, that's ridiculous. So what people did is they designed assemblers. And assemblers are basically like a find and replace strategy. Okay? So maybe what'll happen is I've got an assembler that like the value or the byte, this means, there we go. And this is, and so on, and so on, right? So what I could do then is instead of typing 0, 1, 0, 0, 1, 1, 0, 1, 0, you know, no one wants to do that. So I could come here and say, add 2 and 5. And then, and what is that? 4, 5, and 15, right? I would come along and type this. And then this would be assembled into this. That then gets loaded onto the processor. And that's how the processor does its thing. Now, programming like this, although I actually find it amazingly fun, and I know I'm weird. I know I'm weird. You don't have to tell me I'm a nerd. I'm a computer science prof. I know. Although this is kind of fun, and if you're in computer science, you're totally going to do this. I think next year, it's a second-year class, and honestly, one of my favorite classes ever. I loved it so much. Where you actually kind of learn about the nitty-gritty of how these computers actually work, how our computational systems that we've designed, how they actually work. And you'll probably, no, you absolutely will do some assembly programming. So yeah. This code, this assembly language code, is assembled into zeros and ones that then go run on your physical processors. But no one wants to program like this anymore because this is painful. This is absolutely painful. If you can program like this, you could get super efficient though. I mean, it'll take you like 1 billion years to do it, But like, if you really know what you're doing, you can use all these tips, tricks, shortcuts, and whatnot to make your program run so fast, faster than it should. But you can do that. Raise your hand if you're familiar with the game Roller Coaster Tycoon. This was a huge game for me growing up. Yeah, a couple of people here, you're raising your hand, so you're familiar with Roller Coaster Tycoon. Now, that game had no business being able to run on everyone's computers back in 1990, whatever. So what they ended up doing, or what the programmer did, with the exception of like the GUI, the graphical interface, it was all done in assembly. I mean, you got to be some kind of crazy to do it. Hey, I think that would be amazing to do. But he did it. And then because of it, it was so efficient, so effective. I think I saw another question. Ew. Yeah, exactly. Ew. Exactly. I mean, in your second year course, what you'll do in assembly is like, hey, I can multiply numbers. Like, you'll write code to do multiplication, which is non-trivial, but it gives you a sense of how you, from basic simple little operations, we can start adding complexity and complexity and complexity, and then suddenly we have a full-blown computer. What was the other question here? Oh, I just hands up. What's up, Lucas? Do you have a question? Or I guess everyone just had their hand up. If you have a question, go ahead.
I did have a question. So is this basically like creating a map legend for the computer?
Honestly, that's it. It's basically like, oh, when I see this, I'm going to turn it into the proper zeros and ones. Like, add, literally, as far as the computer's concerned, here's what's going to happen. It's going to do basically like this idea. Add is going to be replaced with, I don't know, whatever. I know this wasn't the same, but boom. Done. You know? 2 will be replaced with the binary version of it, and whatever. So yeah, you're right. It is like a mapping. Now let's get on to C, C++. These are compiled languages. So there's actually a way. So when you compile your code, it turns it into like assembly, which then gets turned into the zeros and ones that run on your actual processor. So when you compile it, it'll actually go to like assembly code, into stuff like this. Now, compilers are remarkably sophisticated code. They're remarkably sophisticated software that will convert your code that looks like this into assembly. All right? And there's actually a setting in a compiler. I'm not sure how to do it with Visual Studio, but if you're doing this with just like a command line C++ compiler, there's actually a setting in your compilation where you say like, don't compile it to the zeros and ones, only compile it to like x86 assembly. And x86 assembly is like the assembly language that all these computers use now. So you can actually write code in C++, and then compile it to assembly, and then look at the actual assembly code that represents your program. It's pretty cool. The people who design compilers, year after year, every year there's an update to the compilers and whatnot, they found new tips and tricks on how to take the code to turn it into assembly that's that much more efficient. Efficient in terms of amount of operations having to be done, a number of floating point operations, number of amount of electricity used, and everything. What was the other question? Would VR use assembly? Do you mean like virtual reality? At the end of the day, it would get down to assembly. Any code written that would work on virtual reality would eventually get boiled down to the zeros and ones, the low voltages and high voltages that are going to be piping through your processors and all the components and whatnot. So yeah, honestly, anything that is like electronic or computational systems that we have designed that are electronic, they're all boiled down to zeros and ones. I know I think in the past people tried like ternary ones where you have like 3 values, but it ended up being a nightmare. Long story short, it's amazing what we can do with 0 and 1. As long as we have an encoding and a decoding, as long as we know that this sequence of zeros and ones means something. So we can encode add as 010101. And I know that 010101, within the context of like the processor, it knows that that is that means add. Now, this also always very much obviously depends on the context, right? Because the number 010101 will mean something entirely different if it's like an integer versus an operation, versus an instruction for your processor. So, like, well, what does 010101 mean? Well, the question then comes up, is this an instruction or is it a number? Or is it a, you know what, let's make it a, there, now it's a byte. Is it an instruction? Is it a memory address? Is it an integer? Is it a Boolean? Well, Boolean doesn't really make a lot of sense. Is it a character? Is it a floating point number? Well, it depends on the context. How are we using it? Anyways, I'm now going down the rabbit hole, which I shouldn't do because this is way outside the scope of this class. What's the question here? Okay. They're trying to make quantum computing more common for large scale, blah, blah. I believe quantum has 4 possibilities. Maybe. I'm not actually too up to date on quantum computing. I probably should be a little bit more familiar with it, but until it actually becomes, I don't know, I'll learn it eventually. Anyways, I'm going down the rabbit hole. Long story short, C++ is compiled into like assembly, which then, you know, is like the zeros and ones effectively, you know, find and replace. There's of course a little bit more than finding and replace, because in assembly you can kind of make like subroutines and whatnot as well. But the people that design compilers will make insane optimizations. So like if you write your code a certain way, the compiler's gonna go like, you suck at coding, and I'm gonna just kind of like rewrite it this way, and it's way faster now because of it. That's what happens all the time. In fact, that's why like there's like ways to do like, what is it, like CPP. No, I can't remember how to do it anymore. Like there's optimization levels you can set to your compilation as well. Like if you're compiling using GCC or GPP, whatever the basic command line thing for the standard like C++ compiler, there's like a command line setting to be like optimization level. If you optimize more, it takes longer to compile, but if you optimize less, you know, your code might be slower. What's the question? Quantum has 3 up, down, and undetermined, so the compiler is magic. As far as I'm concerned, the compiler is magic. I had an opportunity to take a compiler course, and I ran out the door the other way. It said like, you know what? This is for some engineers to figure out. I don't care. Don't be like me. I should probably learn that stuff eventually in more detail than I do now. But the point is, the compiler is magic. It'll take your code. It'll basically rewrite chunks of your code to be more efficient, and then there you go. Your code's in great shape. So that is a very long-winded explanation to your simple question, although I did get me into a segue into talking a little bit about how these things actually work, right? Because sometimes as computer scientists, you know, I could say, oh, I don't really care about how it works in the back end, because I'm thinking of computation not in terms of how these computational, like I'm knocking on my laptop right now, but I'm thinking of these things not in terms of how these things work, but in terms of what computation is in general as a high level idea of these steps. Basically, I could execute like bubble sort on a group of people and sort them by height, but I don't need a computer to do that. I don't need zeros and ones. I could just follow the rules of bubble sort and it'll work. That's just how it is. So we like to think about computation that way a lot of times. But at the end of the day, it is really important and really interesting to see, okay, great, but how do these things work? And it's always kind of interesting to get a peek into the magic back end of these computers. But anyways, back to Python versus C++. Oh, and there actually was something I was going to say before that tangent, was one thing that and I know I said this at the end of last lecture, the one thing I am really pleased with is the amount of, like, I know I said it last time, I'm going to say it again, just for everybody again anyways. Last semester was, in-person classes last semester was tough. Everyone's wearing their mask, everyone's socially distanced, you feel really alienated even though it's your class. The amount of engagement and participation from students. Now, I'm a prof that really likes to have a lot of engagement and get feedback from the students during the lecture. It's how I do my thing. But because of the circumstances last semester, that didn't work well at all. It was difficult to kind of get working smoothly. And I think that negatively affects the class, negatively affects me. Anyways, one thing I love about the online format is, and although it wasn't so much today, maybe because I just went on a rant where there may not have been many relevant questions, but I really do like how people are asking questions in the chat. I like that people can turn on their mics and ask questions. I like how people will ask questions in chat and other people will answer them. That's huge. That is so good that you're doing. Keep that up. It makes the class so much better. It's better for me. It's better for you. Engagement is it makes the class a lot more interesting. So do make use of the chat, because I don't know, it'll make the course that much more better for everybody. So keep up the good work about this participation. And obviously not just the same people over and over, just I want everyone to be participating. Again, also, I always say, if you have a question, chances are half the class has the exact same question. So don't be shy about asking a question. Anyways, let's get back to slides. Okay, so yeah, this example, great. We've just nested them. So the long answer to your question of, is it more efficient to do it this way? At the end of the day, it's probably turning the code into the assembly into the exact same thing as if it was like done this way. Okay, a while loop. So in Python, here's our while loop. We start a counter. I started at 0 because why not? Well, C is less than 5, so we know this is going to loop 5 times. Although C will never get to 5 until after the loop's done, because it'll be 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. That's 5. So print C is now whatever that is, and then we're good to go. In C++, here's what I would do. I'd say, okay, int C is 0. So here I've declared and assigned C a value in the same line, while C is less than 5. You'll see, just like the if statements, we got to put these in parentheses. I've got my squiggly brackets versus the colon. And here, printing it out. Great. Now, you'll see that I've actually used like this insertion operator here, again, where I'm saying, okay, into the C out, print the string, C is now colon space, end quote, and then also pipe in the value of whatever C is, and then put in the end line thing. And then, pardon me, down here, I've got C++. This is equivalent to plus equals 1, but where like in Python, you could do plus equals 10 and it would take C equals C plus 10. You could do the exact same thing in Python, or in C++. I could say C plus equals 10 and it would do the same thing. But there's an even shorter shorthand where it's C++, or the variable name ++, and that means add 1. Now I heard a question. Okay, in while stuff here, do something. Does the stuff here have to be a true or false statement? Okay. Okay. So your question goes into specifics about reading from a file and whatnot. All right, this is an interesting question because I'm gonna show you. So I don't need this anymore. Oh, I guess I should have int main. Okay. In most programming languages, the thing's ultimately going to be a question that's true or false. It's going to be a Boolean value, something that gets evaluated to a Boolean value. And a lot of times if you're reading from a file, you'll say like, is file end of line? Or like EOF end of file. Like it's a question to say like, is the file empty? And you can be like, keep reading from the file until you see the end of file thing. Okay, great. Now, in C++, okay, if I say, I'll use an if statement because it might be simpler to get the message across here, but this is going to translate just to the loop. In Python, if I say, right, this is fine, right? But, you know, if I do this, I've got a problem. Because, I mean, this is a question. It's supposed to be something that gets evaluated to true and false. But this is the assignment. And so here, this is trying to assign the value of 5 to A. And that, of course, does not evaluate to true or false. I need this. And that's going to be, okay, that's asking the question, is it equivalent? Now, in C++, let's say int a equals 3, I don't know. If a equals 5, what the heck? Okay. And then I don't know, else. Oh, right, this is C++. Can't do that. Okay, and then I'm just going to take this, copy, paste, must have been false. Okay, great. Okay, I'm just building it. Give it a second. Poor computer. Oh, I guess it finished. There. Must have been false because A's 3 and 3 is not equal to 5. This should not blow your mind. If I go here, I now run it. Must have been true. Great. Now, when I was here, this said it was false, right? Let's see what happens if I do this. Well, this doesn't make any sense at all, does it? I mean, it actually does make perfect sense based on how this code was written. But it doesn't make any sense because, I mean, presumably you meant this to be A equals 5. But imagine you had this typo and suddenly your code's like, yeah, it's true. I mean, of course A is not 5, but imagine that you assume that this code worked perfectly fine. What the heck is going on here? Because A is in fact not 5, but suddenly it's actually running this statement. Well, here's the thing. First, if we go back to like C, Booleans really aren't a thing. You just have zeros and ones. And the rule is, if you have something that's value is 0, it's false. If you have anything that has a value of not 0, it's true. So here's what's happening. In fact, maybe I can actually make this that much more explicit. std. Oops. Huh? Maybe I can do it this way, or maybe it won't even let me do it. Okay, let's see. Okay, here we go. In C++, when you assign something, when you assign a variable a value, so okay, must have been true. A is 3, that I'm saying A equals 5 now, I guess. It's saying must have been true, so this code ran here, this code didn't. And then down here we've got this 3. So in C++, when you do an assignment, the assignment actually returns the thing, the value, which actually kind of allows you to do something like this. Equals A equals 3, 5, whatever. Because what this is doing is saying, okay, 5 is A, and then this actually returns 5, and then B becomes 5, for example. Now here's some questions. Would print true because C++ returns true when never mind, you just answered that. There you go. See, you know where I'm going. So this returned the number, it printed out the number 3 because, well, assignments do in fact return whatever the value was, the value being assigned was. Did I word that right? Wait. Okay, look, this is actually awesome. So Visual Studio, you might not be able to see this because the resolution might be pretty low, but hopefully in the actual recording it's a little bit better. Here, C++ is actually saying, incorrect operator, assignment of constant in Boolean context. Consider using equals equals instead. So Visual Studio is actually being very helpful here. Not many IDEs would be this clever. But Visual Studio is basically saying, I don't think you want the assignment here. I think you want equals equals, which is of course true. But the question still remains, why the hell did it say it's true when I was saying, well, A is 5? Well, that's because here's what happened. A is 3. It goes here, then it goes, oh, no. A is now 5. In fact, just to prove that fact to you, we'll see down here that 5 should be printed out. Uh-oh, what did I do wrong? Cannot file. Oh, do I have it open still? I may not have closed the thing properly, so it might not like to run. Okay, here we go. So see, look, A is 5. Why? Well, because I just assigned it right there. So here's what happens. Remember, in C++, 0 is false. Anything that's not 0 is true. So it says, okay, A, you're 5, and this returns 5. So this basically says if 5. And as far as C++ is concerned, 5, well, that's true. So print this out. End of the day, you gotta be very careful with this in C++. Many other programming languages won't even let you do this here. They just be like, no. C++ will let you do it because of course C++ assumes that you're a genius. You're God. You must know what you're doing. If you wrote it like that, you meant to do it that way. So C++ lets you do this. This is another example of C++ gives you a lot of freedom, a lot of rope. But of course, we all know what you can do with a lot of rope. So, long story short, we best be careful about this one. Okie dokie, we're almost out of time. We got a couple more minutes here. Okay, so here's another example. A while loop with like just using a condition or something. So stop is false. Well, not stop. Print C is now whatever that is. Add 1. If C is greater than or equal to 5, switch this to true, and then of course that'll happen. C++, same idea. But in C++, and similarly in Python, because in Python, if you wanted to know if something was not equal, you would say exclamation point equals. Exclamation point means like not in C++ and many other programming languages. So if you say exclamation point stop, that means not stop. So if stop is true, this becomes false. If stop is false, this becomes true. Otherwise, same idea. Nothing really new here. Aside, I mean, we just did talk about it a moment ago, but C++ is the same thing as C equals C plus 1, which is also the same thing as C plus equals 1. Suppose here's a good place to end, but I did hear another boop question. Would there be a use for an if something? There totally could be. It would probably, like I could maybe come up with an extremely contrived example, but I'm sure there must be a case where it is useful. I've never done it in a way that's useful, and I suppose if you program something in such a way where doing what you're asking is useful, you could probably program it a slightly different way where you wouldn't have to do it that way and eliminate all possible confusion. Anyways, yeah. Any questions before we wrap up for the day? Also, I like to see that amount of interactivity in the chat. If anything, I'd like to see more, but anyways, so 0 is false, and anything that's not 0 is true. But in C++, we do have... Well, here, let's see what happens if I do this. Let's just see. It might actually print out true. I don't know. Let's see. Ah, look, it says 1. I printed out true. It said 1. What's up with that? Print out false. Now, note that by default, it'll be 1. But really, anything that's not 0 is true. So I said print out false, but it gave me a 0. What's up with that? Anyways, good question. Good question. Throw a null in there and see what. Okay, well now let's not get to null real quick. Real quick, what does the exclamation point do again? It is not. So it means if you have something, let's say I have 5 equals. No, let's go here. Same thing as that, kind of. So if I had something not equals 5. This is saying like, okay, is something not equal to 5? So this will be true as long as something isn't 5. I could do this. which would mean the same thing. Or let's say some bool, it's going to be true or false. If it's true and I do this, suddenly this evaluates to false. This, if this is false, this is true. And if I do this, this is like the same thing at like not something will of course undo the nodding that you've done. But anyways, we're going over time. We will see a bunch more examples of the exclamation point. But anyways, hopefully you had a good time today. And also you can also do not ... So if the inner statement is true, then it be effectively, yeah. Get line my file. How does something like this work? Is it the same as probably get line? It's I'd have to look at like the actual function and look at get line and see what it returns. Get line might be returning like the number of characters in a line, and if the number of characters is anything but 0, then it's going to assume it's true. So yeah, it probably is actually doing basically that idea. But until next time, enjoy the rest of your day. See you later.